Okay, everyone. This is going to help you with your Nature of Science worksheet today, the second two pages, the ones that have the bar graph and the conversions. We're going to do more of this in the coming days, but I thought I'd give you a head start to practice. What we have here is we have a line graph. A line graph is really good at showing a continual change in events. So right here you can see on my y-axis, I have my dependent variable. It's dependent on what happens on the x-axis. Okay? If the x-axis doesn't progress, the y-axis, or my vertical axis, cannot change either, right? So if I stop time altogether, I wouldn't be in pain. So what's happening here? Let's imagine that uh, there's somebody waiting for a test to start, like maybe they're checking to see how much pain they'd be in if they stuck their finger with a pin or something like that. So up until about this time period right here, up until about this time period, there is no pain. So you could probably assume that they have not been stuck by the pin yet, right? All right, but as our time increases along the x-axis or the horizontal axis, you can see that all of a sudden at around this time, there's a dramatic shift in the amount of pain that there is. The pain increases at this time, right? And then it continually increases at a constant rate because the line is straight, and it reaches its max amount of pain at about this time. So if I had a number here, that's the time that you would put, okay? Now, we do graphs like this to make a visual representation of data to test our hypothesis, right? Our hypothesis is an educated guess that we're going to put into an experiment. We use an experiment to test a hypothesis. If we do enough tests, we can turn it into a theory. A theory is something that has been tested over a long period of time and has been confirmed, right? It makes a general example of what's going to happen if certain conditions are met. And over time, if we find that this seems to be the case everywhere at every instance in time, that we end up coming upon a scientific law. It's a truth of nature that happens to always be true. Like, we find out that human beings have nerve endings that experience pain and send those signals to the brain. So that'll be like some sort of scientific law, right? Okay. Now, our independent variable, I want you to associate these three words, x-axis, horizontal, independent, right? Regardless of if I'm in pain, time is always going to go forward. It's independent, like an independent woman don't need no man, right? Pain on my y-axis is the vertical up and down, and it's dependent on time. Now, we might use a control, right? We have somebody just waiting without any pain, right, in the exact same location to make sure that there isn't any other reason why this first person could be feeling pain, right? Maybe there's like a microwave gun pointing in the room, and maybe that's what's causing the pain. So we use a control, something that's going to more or less not be changed as a basis of comparison. Okay, so that's line graphs. Now let's look at conversions. Okay, you've probably seen this before. The mnemonic, King Hector demanded, and we're going to put our base unit meter for this one, more, but it could also be liter or gram. King Hector demanded more delicious chocolate milk, right? Just remember our base unit meter, liter, and gram. Meter, liter, and gram. Okay, really, really easy. Wherever I'm starting, let's go ahead and just start right here. We got 10 centimeters, so centi is where? Centi is here. This small m is for milliliter. Okay, so that's milli. Lowercase c is centi. Okay. D is for deca, uppercase D. H is for hecto, it's 100. So what you do, let's say we got centimeters, right? So I'm going to take centimeters and I'm going to walk over how many steps to meter? 1, 2, right? So I'm going to take the decimal. Imagine there's a decimal right here, remember? And just go 1, 2. So that would be how many meters? 0.1 meter, a tenth of a meter, okay? Let's look down at 10 liters would be how many milliliters? Okay, so I'm going to go ahead and erase this stuff. There we go. So we got liters, so liters is my base unit right here, and you can write this on your paper too, K, H, D, M, L, G, D, C, and M, right, for all the different beginnings. So we're starting at liters, and I'm going to jump which way? To milliliters, right? 1, 2, 3. So I take the decimal and go 1, 2, 3. And for each little bubble, I fill in a 0. So how many is that? That's 10,000 milliliters, right? Super easy stuff, right? Okay, kilograms. So where's kilograms at? Kilo is here, way up here. Kilograms to centigrams, right? So that's going to be a lot of jumping. Let's try that out. Okay, kilo, ready. 1, 2, 3, 4, 5. Okay, so we have to do 5 jumps. So I'm going to take that decimal and go 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's kind of nasty, so let's write it over here. 5, 0, 1. I can't even see. 2, 3, 4. 1, 2, 3, 4, 5. Okay, 5 zeros like it. Alright, that's a big number, so put the decimals there. There you go. So 4,500,000 centigrams, okay? Let's go down here. A little tricky one here. Milliliters to centimeters. So you know that you have meters, liters, and grams. These aren't really even the same things, right? Liters and meters, these are different units of measurement. But you know volume, if you remember from geometry, is base times width times height, right? So if you were measuring it all in centimeters, you'd have centimeters times centimeters times centimeters for length. These are all lengths, right? Even though they're called base, width, and height. So centimeter times centimeter times centimeter, just like x times x would be x squared, right? Centimeters times centimeters times centimeters would be centimeters cubed, okay? So actually, centimeters cubed is a unit of volume. And it turns out that it's 1 to 1, okay? So if I have 50 milliliters, I also have 50 centimeters cubed. And you need to know this for the medical field, right? So in the medical field, they use milliliters and centimeters cubed, right? If you're making compounds or something. All right, I'm going to go ahead and make another video about this last problem right here, and I'm going to show you maybe an alternate way to do this same work, okay? All right, good job.